This is Raven, a micro UAV built by engineering students at the University of Central Florida. Built over the course of a few months, this aircraft sets off to achieve its mission.
My name is Lawson McKinney. I am a mechanical engineer, and the project I'm working on is the micro UAV Black Team. I'm doing it for just my love of aviation. Each part of the aircraft has a different section of materials and stuff. Mainly we use balsa wood just for its lightweight capabilities and how strong it is for lengthwise. We also use carbon fiber to reinforce the aircraft in certain areas, much like the wing and the tail sections, mainly the booms that are extended from it. And we also use some PLA for certain parts that we can't just easily manufacture.
So my name is Ivan Mendoza, and I'm an aerospace engineer. I started off very fascinated with rockets and stuff, but as I progressed at UCF, I kind of realized planes were kind of more my thing, and I decided that for my senior design project, I was going to make a UAV.
My name is Tyler Krasher, and I'm an aerospace engineer. I chose the UAV Black project because it looked like it was a fun challenge, as well as it was good to work with the team and overcome that challenge. I have made RC planes in the past, as well as I have made drones, robots, etc., all of the sorts. That knowledge helped me in terms of dealing with the controls, control surfaces, all of the above.
My name is Nicholas Papavasilio, and I'm an aerospace engineering major. I chose this project because of my love of airplanes, and then also the challenge of making a rear propeller plane, as it's not very popular. I feel like I've learned actually a lot. I felt like before I knew more of flying experience and just aerospace, learning all my classes, but applying to what I've learned into a project, as well as flight experience. I've flown before, fly airplanes, but seeing the full design behind it is something I've actually really enjoyed.
My name is Chase Heckroth. I'm an aerospace engineer. I took this project on because I've always kind of had a love for the aerospace factor. I want to work with Boeing, Lockheed Martin, something in the aerospace defense contract, field defense contractor, something like that, and something like this is a way to get my foot in the door.
So my name is Javier Arocha, and I'm studying aerospace engineering. I have a minor in mechanical engineering. When I was studying in Venezuela, I didn't have any opportunities to actually go into the aerospace industry. And when I moved to Florida, literally the same time Elon Musk was sending rockets to the space. And once I got my minor in mechanical engineering, which was a very natural choice, I just decided to switch to aerospace and move to Orlando and study with the University of Central Florida.
So our mission is to create a long-range payload micro UAV, and our constraints have been to use a pusher setup, and we have to use electric power. So it's been quite a challenge to work around that because pusher propellers aren't very popular, so it's been very difficult to build around this type of thing.
Most propeller aircraft are front propeller just due to ease of manufacturing and direct airflow into the propeller. With a rear propeller, direct airflow is blocked by the fuselage as well as the tail and the wing section. So it was a challenge that I kind of wanted to take on.
Originally, we were supposed to go with a T-tail design. After some discourse with the team, we realized that wasn't the best option due to adverse effects it would have on the aerodynamics. And so we settled on a twin boom design. It's used very widely in commercial industry and very successfully for pusher propeller planes.
During the fabrication process, we would be using things like laser cutters, 3D printers for the PLA. We were using drills and sandpaper, just little things like that. Wood glue has been our strong suit for adhesive, and we've also used a lot of plastic bonder as well.
So a circular fuselage distributes the stress evenly around the fuselage, reducing the risk of a stress fracture at the corners compared to a square fuselage.
We decided to use a really big battery to further extend our range as much as we can, but we chose a specific battery with like low weight but like a lot of charge. So theoretically, our airplane should be able to fly like maybe 2 to 3 hours continuously. In order to make our UAV long range, one of the design choices we decided to make was to have a pretty ridiculously long wingspan for a plane of its class. Having to haul this plane around was going to be a challenge, so what we decided to do was make most of the parts of the plane removable so that we could actually like move the plane around without struggling too much.
To elaborate on the design, let's take a closer look on how this aircraft works. Starting with the payload, the nose cone uses Velcro to attach itself to the front, allowing for easy access. And then, the 32-ounce Gatorade bottle can be easily removed through the front of the aircraft. To make the wings removable with this design, the booms must be removed. Using special mounts that slide forward, they can be easily lifted out of the wings. After the booms have been removed, the wings can be easily slid off, along with the carbon fiber rods. Reaching your hand through the fuselage reveals a pin that can be slid off to remove the wing box. This wing box allows access to the entire midsection of the airplane, allowing you to interact, modify, and configure all aspects of the aircraft. Here's some more technical information on the rest of the UAV. Thank you for taking the time to view this video, and I hope you get to catch your plane fly in the sky soon.